A guide now to the stars and constellations visible during autumn in the northern hemisphere and spring in the southern hemisphere. Encyclopedia Galactica.
In its annual orbit of the Sun, Earth is approaching an equinox. It's late September, autumn in the northern hemisphere, spring in the southern hemisphere. For a few days, everywhere on Earth has an equal amount of day and night, the equinox. It's a good time to study galaxies, for Earth is looking outwards, away from the distractions of our own galactic center. Exotic stars and wondrous clouds adorn the celestial stage. In the southern skies can be seen the small Magellanic Cloud, a satellite galaxy to the Milky Way. We know about the nature of stars and galaxies because they each radiate a different spectrum of light, a fingerprint. In the region of Orion, here's the light of 4 major stars analyzed by spectroscope, the fingerprints or spectra of Rigel, Sirius, Procyon and Pollux. With Sirius, for example, its spectrum can be matched against a laboratory scale. Where lines coincide, certain elements exist. We can tell what Sirius is made of. We can also discover its direction of rotation. Light shifts towards red if a body is retreating, towards blue if it's advancing. It's known as the Doppler effect. In the case of galaxies, stars moving towards us have a blue shift, and away from us, a red shift. Clues from the cosmic code. The autumn sky in the northern hemisphere. The constellations as we look north. Low in the sky, Ursa Major, in some places out of sight. Gemini, the twins. Auriga, the charioteer. Perseus. Cassiopeia, the queen. Cepheus, the king. Hercules, left over from summer. Draco, the dragon. And Ursa Minor. At the center of things in the north, Polaris. Directly lower in the sky, 7 bright stars that form part of Ursa Major. They're variously known as the Big Dipper, the Plough, and the Emperor's Chariot. One of the 7, Mizar, has a companion, so close it was used as an eyesight test in armies of old. Through a powerful telescope, Mizar is not 2 stars, but 3. The larger companion is Alcor, too far from Mizar to make the pair a genuine binary. The smaller one qualifies. We see the sky in 2 dimensions. Were we able to travel around the 7 brightest stars of Ursa Major, we'd see them in 3D. In other words, we'd realize that their distances from each other, as well as from us, are quite different. Far from the picture they present to Earth. Now, if we travel forward in time, about 100,000 years, the 7 stars will realign to look something like this. If we reverse the process by traveling back in time, they'd form another configuration. The patterns we see today are a single frame in a movie. The cosmos is ever changing. This is how the 7 stars would have appeared 100,000 years ago. More like a spear than a plough. Again, the autumn sky of the northern hemisphere. The view is to the south, and these are the constellations. Delphinus, still around from summer. The great square of Pegasus, the flying horse. Straggly Andromeda, the chained maiden. The three sides of the triangulum. Just beneath, Aries, the ram. And the two fishes of Pisces. Lower down, the sea monster Cetus, sometimes called the whale. To the west, Aquarius, the water bearer. And finally, the sea goat, Capricornus. Top center, the most distant object visible to the naked eye. It's the great galaxy of Andromeda. Lying in the direction of the constellation of Andromeda, the galaxy is like our own, a spiral of over 300,000 million stars, plus a couple of satellite galaxies. This one was probed by the Hubble Space Telescope in the early 90s, satellite galaxy M32. From the clarity of Earth orbit, Hubble peered into its heart. Each dot is a star shining like a sun, light which takes well over 2 million years to reach us. Low in the sky, through binoculars, a faint blur. Through a big telescope, the magnificence of the Helix Nebula. A cloud of dust and gas expanding at perhaps 40 kilometers a second. A dying puff of energy from this central star, whose corpse will be a white dwarf. High up, between the Triangulum and Andromeda, the faint galaxy M33. Visible in binoculars, M33 is one of the best face-on spirals in the sky. We're still looking south, but from the more southerly latitudes of the northern hemisphere. Low in the sky, the constellation of Piscis Australis, the southern fish. Here is the star Formelo, with an exciting possibility. There's recent evidence that it's surrounded by a cloud of cool gas. Such a cloud gave rise to the planets of our solar system. It's still late September, but we're now in the southern hemisphere looking north, and it's spring. To northerners, the constellations look upside down, but to southerners, they are the right way up. Top center, in Aquarius, a double act. A red giant and a white dwarf, the hapless giant heaving and blowing, the dense dwarf tugging matter from its distorted companion. And periodically, a gigantic nuclear detonation. R Aquarii, a very variable star. The southern sky, looking north. And now, looking south, towards the polar region. The Southern Cross and the Milky Way are low on the horizon. These are the constellations of spring. On either side of Hydrus, the little snake, like pieces broken from the Milky Way, are its two satellite galaxies. They're called the Magellanic Clouds, both visible by naked eye. The small Magellanic Cloud is only a tenth the size of the Milky Way, but it's more than 10 times closer than Andromeda, our nearest big galaxy. The large Magellanic Cloud is maybe twice as big as the small. Both are 180,000 light-years away. One day, we may all collide. Bottom right in Ara, through a powerful telescope, a beautiful nebula. A majestic cloud of red hydrogen and black dust, our last picture of spring in the southern hemisphere.